Welcome to Talkin Science. Matt Miller with you. We are just 2 days away from the end of the year that has been 2022, and I tell you what, has been absolutely amazing to see what has happened throughout the year. We're going to have a full wrap up from all of our chats, all of my chats with Dr. Brad Tucker over the past year. Obviously, Brad's been beaming in monthly. We've been recapping the biggest stories of the previous month when Brad beams in on that first Tuesday of each month. Next year, Talkin Science going back to a weekly time slot with experts from each of the stories that we're going to be covering throughout the year. So the other 3 Tuesdays of the month, I've been bringing you the headlines of the stories. The plan next year is to bring you those headlines and then chat with the people making the news. Something a little bit different from Trekzone for Talkin Science. Let's roll the opener. Let's get into this year in review, an abridged version, if you will.
This is Trekzone's Talkin Science.
Yes, indeed, it is Talkin Science. Thank you very much to Ross, our voiceover guy, who's been doing those intros all year long. Don't forget Trekzone membership available by clicking the join button under each video on Trekzone's YouTube channel. For less than a cup of coffee a month, you get behind the scenes access and early release podcasts of all of the stuff that we're doing. We're back into it next year, doing a lot more content than we have done this year. So now is the perfect opportunity to join as a member, get in on the ground floor for 2023's podcasts. It's going to be absolutely fantastic. Really looking forward to bringing you everything that I can. I do see a couple of issues with the key here on the shot. We are going to fix those in the weeks ahead and get better at this as I bring you another virtual set here on Trekzone. Something a little different than just a still image of the city. We've got some new graphics coming in the new year as well, so be on the lookout for all of that to come. Trekzone membership will give you the early lowdown on what is to come. You can also click thanks under Trekzone's videos on YouTube. That'll send a one-time contribution through the YouTube system through to Trekzone's AdSense account. You can, of course, also go to the trek.zone/PayPal, contribute directly to the 20th Anniversary Production Fund. That is going to be a massive live stream as part of Trekzone TV coming up on the 20th anniversary of Trekzone.org. First started July 10, 2003. Started podcasting July 10, 2013. Now, July 10, 2023. Going to be doing something a little bit big, a little bit milestoney to celebrate it. Be on the lookout for all of that. But of course, we are here to wrap up 2022 in science. Trekzone has been extending its reach in podcasting beyond space, beyond science fiction and Star Trek specifically, to feature science and space news. Meeting Dr. Brad Tucker and bringing him on board in those early episodes weekly, every Tuesday. This year, he got a lot busier, so he was only available the first Tuesday of every month. And today, we're going to dive through the archive of our 8 chats this year as we spoke with Brad and wrapped up the biggest stories of the previous month. It's helped me here on this year in review to really bring you the highlights of what is to come. Without any further ado, let's get straight into our look back at the year that was science and space from us here at Trekzone.
The United States, Australia, Canada, France, Germany, New Zealand and the United Kingdom signing a joint vision document that calls for greater cooperation to prevent conflicts in space. The Combined Space Operations Vision 2031 outlines cooperation, coordination and interoperability opportunities to sustain freedom of action in space, optimize resources, enhance mission assurance and resilience, and prevent conflict. That came from the press release, of course. Essentially, a lot of words, Brad, to say that the 7 nations will band together and help everyone avoid fighting in orbit.
Yeah, and it really is this kind of, we're starting to form an alliance isn't quite the right word, but it kind of is a cooperation, a group to uphold the peace and law of space. And this becomes quite big. Most of these countries already participate in defense aspects on the ground. 5 have signed the Artemis Accords. France and Germany have not. They are still helping with the Artemis mission, but there's also some issues between the Moon Treaty and the Artemis Accords. And what it's really trying to establish is we will uphold, practices, use, sustainability in space. And it really is a slight or undertone against the Russia and China-led effort to the moon, because this is really what it's all about, in particular when we get to the moon, and upholding those principles. And as they kind of quote in a quite, I think, scary way, in the instances of armed conflict, this is definitely something that is at the real forefront, which it hasn't been in the past.
Well, we've talked about everyday reliance on satellites, Brad. This vision specifically addresses that and aims to defend it with military power. As you're saying, getting into this armed conflict stage, certainly an escalation, and the way everything's going at the moment in the last couple of weeks, certainly an escalation on everything. How do you personally feel about peace through power, as it were?
Well, it's interesting because, this came out on Thursday morning. We had the Russia anti-satellite missile test that really stirred the hornet's nest with that missile launch. We then had, some issues with Russia and China before. And it's interesting because you go on one saying, hey, we want to uphold the Outer Space Treaty, which is for the peaceful use of space. So how do you reconcile upholding it through militaristic means, a treaty that says no militaristic aspects? And it's also starting to get away from the current vision of, it is not just armed conflict. It is about, how do we interfere with satellites? There's a very important undertone about sustainability in the space junk problem. And this is a very interesting one. Again, not just creating more space junk, but how do we monitor it? How do we control it? How do we get rid of it? Something Australia is doing in a big way. So really trying to go into that holistic view of how do we can control space. What I was always interested in, how does this apply to, say, the private corporations and the rise of mega constellations, for instance? How is that going to interfere in the operations and safe use of space when a lot of people quote as saying it poses a risk? So it will be interesting to see how this all plays out, but clearly it is at the thinking of the government from not just a space exploration side.
Well, in an American article on this one, and you just touched on it there as well, they mentioned the Russian anti-satellite missile test back in November last year. That destroyed one of their defunct satellites, caused debris to go flying everywhere, threatened the space station as well. Now, that's one very real threat to the peaceful use of space, as you say. They're not the only country with that capability, though. We'd be remiss in not mentioning China, India, and even the US testing such weapons before. What is the defence against those, putting lasers on the satellites that we want to protect, or some sort of chaff or something like that, countermeasures?
I mean, there's lots of options. There's changing these deorbiting, there's intercepting the missile before, but I think the point is, you're right, multiple countries possess this, including one who has led this pact. The U.S. was the first one to do this, by the way. Let's just keep that in mind. But it also then is really thinking about, well, what may happen on the moon as well, and that is becoming in a very big way, where the treaties and laws maybe are even trickier to navigate, and the rules are even trickier to navigate. So I think what we'll start to see is, and this is kind of what they're hinting at, is effort put in building defensive capabilities in this area, again, which is not something that's been the focus. We've been talking about operations, command, technology to better space in a realistic way, but this is purely starting to look at how do we defend in a different way, and that has a lot of different tones and angles from what we're currently doing.
Another one to watch and see what happens, especially with this escalation and the potential for satellites to be knocked out of orbit as part of ongoing operations from Russia. Well, the $10 billion successor to the Hubble Space Telescope is now fully focused and aligned, Brad, with light bouncing perfectly off its mirrors to form incredibly detailed imagery in all four of its instruments. We're going to see those in a second. Finally, a series of events that have gone off without a hitch for the team at the James Webb Space Telescope.
Yeah, look, obviously it was a long path to get into space, but since it's been into space, they've been nailing them. And the key here is kind of seeing in this image is the telescope was folded, and all of those mirrors, when they were folded, were slightly off of position. So the segments had to be perfectly aligned. We're talking about less than a micron or a micrometer precision. So, way better than a nanometer or sorry, a millimeter. So we're really talking about precisions that are on the scale of, something that is ultra fine in order for the alignment to be perfect, in order for the focus to be perfect, and then in order for the light to come through the telescope and optimize it. Because you don't want to just put the telescope and then have the images slightly blurry. So it's been a process over the past couple of months to get all of those mirrors slowly into position. It's kind of a lot of, is one or two better? And then you move it, because obviously all of those little segments at Honeycomb can move independently. So you can't just say move this one into position and then move this one. They all have to move kind of in sequence and in syncing. But that is now, as you said, done. And now all of the light is focused and coming through those instruments on James Webb.
Now, one final calibration check on the data delivery side of things, which could take another couple of months. Agonising details, Brad, that are well worth checking off, but surely everyone is champing at the bit to get this one going.
Yeah, and look, and the last stage is actually the fairly normal stage, and what we mean by that is every new telescope or camera or instrument has to be calibrated. Has to perform. How it has to work. Even when you're taking your phone. And you take an image, you want your camera to focus right, and you got to make sure the lighting's there. These are all little things that the telescope has to do. We also have to do the base level calibrations to know that when we measure something, what it's measuring. So, but this is very standard and very kind of normal process. This is the normal process, we say, as part of commissioning. So the fact that all this really unique stuff that was just unique to James Webb and how it was built is done and working means it's a fairly, I wouldn't say straightforward and normal, but a fairly clear process that has been done lots of times, and we know how to solve when problems arise and how it works. A lot of these other things were such a first-time situation that it took a lot of debugging and work to make sure it could be solved. So definitely the home stretch here of the telescope. And they always wanted to be online by the end of June. That was the goal, 6 months roughly from launch being December 25th. They're on track for that. I think that's the exciting thing. They are on track for what they envision as a kind of a 6-month phase. And then the awesome science starts.
Yeah, absolutely. And looking forward to some of those images being relayed by our friends at the Tidbinbilla tracking station. Well, these are the images released by NASA. They're engineering samples, so they're not pretty. They're not designed to be pretty, but they are certainly showing off different views of the Large Magellanic Cloud. Something that we know, something that we've seen plenty of times before. We know what it should look like. Sizes and positions of the images here depicting the relative arrangement of each of Webb's instruments as they pick up the light coming from the telescope's golden mirrors, including that 6.5 metre wide primary reflector. They may not be intended to be exciting, Brad, but really they are, aren't they?
Well, they are, and especially because people have already comparing them to previous images, say from Spitzer, other infrared telescopes and things like that. And the clarity and improvement of the image is just dramatic. It's not even, comparable in terms of what you're seeing when we compare it to a previous image of these areas and what James Webb is seeing now, especially the MIRI image of one of the nebula parts of the Large Magellanic Cloud. You just see, you in previous images, we only actually see a few stars plus a little haze. Now we see the brighter stars very crisp plus all that background stuff. And so it's delivering exactly what we thought. We're not only seeing fainter objects, but we're seeing brighter objects in clearer and more detail. And that's always been the name of the game: better resolution and better sensitivity, how far we can see.
Well, from the butt of jokes to a mysterious moon orbiting Saturn, NASA's announced we're going to be learning a little bit more about the outer solar system in the decades ahead, Brad.
And this was part of the Planetary Science Decadal Plan. So in astronomy and in planetary science being just exploring our solar system, they kind of have a group of scientists come together that represents everyone, say, this is the priority that we think based on feedback from the community, what people want, what are the science questions, and then make a recommendation saying, this is what needs to happen for the next decade. And in planetary science, they list what are going to be the two or few missions that should be focused on. Now, that doesn't mean that they're going to happen next decade, but they essentially start next decade. So obviously, we have new missions already in the works and flowing. So they say now over the next decade, start to build these and design them and get to them their places. And as he said, two of the places are Enceladus, the moon of Saturn, and Uranus. And both have very good, interesting reasons why they're at the top of the list, but also why they haven't been explored previously, but now. And this is based on a lot of new understanding, a lot of new data, and a new insight into what we think we can gain from studying these places.
Well, unlike Jupiter and Saturn, Uranus has only had one visitor from Earth, a brief flyby by the Voyager 2 spacecraft in 1986. And ever since, astronomers have been lobbying for a dedicated mission. What curiosities does Uranus potentially hold, Brad?
Yeah, and I think it's important because the Voyager didn't even really orbit, right? We're not talking about other moons and planets that have missions that just orbited and spent years at it. Voyager literally just flew by, took a couple of images, and that was it. Uranus is exciting because Uranus and Neptune are what we call ice giants, for one. They are different than the gas giants of Jupiter and Saturn. We've changed our understanding. Jupiter, Saturn, Uranus, and Neptune are not all the same. Uranus and Neptune are very different from Jupiter and Saturn. And they're actually quite common when we see them in other star systems, exoplanets. So that just gives us an understanding of this whole new type of planet that we're now appreciating is fundamentally different. The way the weather acts on Uranus and by extension Neptune, the composition, some of the moons, as you said. So there's a lot to understand because we just haven't studied it in detail, but we now see its bigger role. And look, to be fair, Jupiter only had its first dedicated mission with Juno now, which is going on, and that was a recommendation from 2 plans ago. So it's, now the technology is changing. We can spend time on some of those outer, larger planets and places that we generally haven't had a chance to visit. The current missions have all been focused on some of the moons, with missions planned to Europa in the works and Titan in the works, visits to asteroids. There's been a lot of that stuff that's been the focus. We had New Horizons that visited Pluto. So now there's a bit of time to focus on some of these other ones because people realize you can't just only focus one object. We have to kind of spread it around across all of them.
And how would you be as Uranus? You watch another probe go past, the New Horizons spacecraft off it goes to Pluto of all places. Pluto gets its own mission, not Uranus. But anyway, it's coming.
Look, it has been
soon.
The forgotten child and plus the laughed at child as well. And I think it is. I think we're also benefiting from just cheaper, quicker technology. We can build probes easier. They can do a lot more science. We can get better bang for our buck in terms of what the measurements are. So we're benefiting from that as well when it comes to exploring these places. New Horizons wasn't that fancy, and in terms of it took 10 years to get to Pluto. It only did a flyby. So at least with Uranus, Voyager had imaged it. We hadn't had any images of Pluto, and it just kind of zipped past it. But it at least had some instruments on it, where the belief is with this Uranus probe, it will be able to do lots of different measurements like we've done in Jupiter and Saturn, and also explore some of the moons of Uranus in addition to just the planet itself.
Well, let's talk about Enceladus now, or Enceladus, the 6th largest moon of Saturn. Just like Uranus, it was discovered by William Herschel. And we didn't know much for 200 years after discovery until Voyager flew past in the 80s. And then Cassini in 2005 revealed a subsurface ocean and loads of ice.
Yeah, it was really the Cassini probe that pushed this into the realms of being very interesting. Again, we kind of knew Europa was interesting because it was bigger, easier to study. Same with Titan and Saturn. But Enceladus, because it was smaller and we had much data on it, there wasn't really much to learn. But when Cassini flew by it, and towards the end of the Cassini mission did some dedicated flybys with Enceladus, and we saw geysers essentially coming off of it. We saw things coming out of the surface, clearly a sign that there was water or liquid, at least with hydrogen and oxygen underneath the surface, meaning that underneath the surface it was temperate, i.e. not just frozen ice, but there was an ocean. Again, like with Europa, that we believe, and some of the other moons, it was a really a game changer. And so it was kind of like, all right, well, we have to explore this one as well. This is just too interesting. And given the technology and knowledge and gain from the missions that will go to, say, Titan and Europa before this mission is flown, it is a good plan, because you can say, all right, we're going to fly to Titan with Dragonfly in 2027. We'll do the Europa Clipper as well. We can gain on what that knowledge is from those studies and build it into our study of Enceladus as well. So very exciting, very interesting, and kind of that very big step into exploring that big question, not just of the Jupiter and Saturn systems, but really these moons, which we think are very viable places for life.
Going to be very, very exciting, and we'll be learning about these discoveries, Titan, Europa, Enceladus, Uranus, all by the time I'm about 60, 65, which puts you at about 50, 55, doesn't it, Brad?
Something like that. It's a bit of a dedication, let's say, in order for these missions. But that's the thing, right? James Webb, as we were just talking about, took 25 years to build and get in there. There are some people that was just their career, one thing. So it is dedicated. These missions do take time, but I think the exciting thing is we are seeing more and more of them, right? It's not just we occasionally get a mission to Mars or somewhere else, or we just had Voyager. We're now planning multiple places in a batch. And this is also just the U.S., keeping in mind. This is just the U.S. decadal plan. Europe also will have its own priorities that it works around it and build own missions. Japan is doing it. So now as more countries build them, there is that greater cooperation and having more missions happening to different places. So, it's becoming quite busy to see them. So, the discoveries will not be, we just wait, 10 years for the next probe, but now every year there's a new mission reporting back new data on a new place in our solar system.
Over at Gilmore Space, our friends completed a full duration test fire last month of the new Phoenix rocket engine. This looks great, Brad.
Yeah, look, and this is kind of their static test, i.e. where they put it on the ground and then they fire it, obviously making sure it all works. This is a big step in terms of how they're manufacturing, bits of this. And I think they're aiming for most of the bits to be 3D printed, in fact, and then manufacturing as far as the third stage. So a big step for them, obviously, because they really are aiming to have a launch, I think, next year, and they're still on track for that. So it's great to see that it is progressing for them.
Absolutely. Well, Southern Launch has picked up another grant from the federal government's Moon to Mars initiative, from one friend of Trekzone to another. This one's going to help them build a mobile launch rail that'll not only be useful at the new Whalers Way facility, but it can be shipped up to the Caniba test range as well. Multifunctional use.
Yeah, this is a good step for them to now easy access between their two test ranges. So obviously, in terms of the development and practical aspects of it, really sensible, very good infrastructure. So hopefully, they can have that flexibility in launch sites and partners, and ease of infrastructure down the road, which is the name of the game here.
Well, Starliner has completed its trial flight after several months of delays, landing safely back on Earth last week, Brad.
Yeah, as you said, this was the third version of the orbital flight test. The first two times encountered various problems. The first time they did launch, but a software problem meant that they didn't reach the right orbit. The second time they had problems with their valves and their cooling system essentially on board. So they really wanted it to work. Obviously, they launched it, as you said, successfully docked, and then returned to the Earth. So a big step, albeit over a year and a half delayed, that they wanted to get right and get it hopefully all checked out by NASA, so they can then start the next stage, which is a human test flight, followed by hopefully full operation.
And looking forward to that. It was a 7-day test flight that saw Boeing achieve all 11 of the mission parameters, or at least to tick the boxes. I can only imagine how little sleep the teams got during that week, though, Brad, as you're talking about there, the third attempt at getting this launch up and running.
Yeah, look, you obviously didn't want a new problem to arise. You didn't want an old problem to resurface. So there's a lot of different aspects there. So it is good that, again, it did work. It wasn't without problems, though. In fact, 2 of the engines didn't properly fire on the way up in the docking stage. It wasn't critical, but again, you want everything to go perfectly to plan. NASA and Boeing haven't essentially said that everything is, done and they're moving on to the next stage yet. Even though, as you said, it did tick the 11 major areas. As long as NASA's happy with that, even though there's a few minor things, they can resume human test flight with it next time. And, and the key here is SpaceX and Boeing were similar in terms of timeframes. They just aren't now. SpaceX is already on Crew 4. NASA has announced a further 5 missions with SpaceX beyond the further 3 they've already had. So, if Boeing really wants to be in it, they have to be hitting everything first time in the next few goes.
Yeah, absolutely. Well, Rosie was the only passenger, a lifelike test dummy fitted with 15 sensors, collecting that all-important data for how humans will fare on a ride to orbit. Fingers crossed, Brad, all is in the green, not only there, but with those 11 mission parameters as well. Obviously, lots of data collected to analyze and have final certification. As you say, they're going to be about 9 flights behind Starlink. Starlink. No, not Starlink.
Yeah, exactly.
That's the internet constellation.
Crew Dragon, yes.
Crew Dragon, that's it.
Very little margin for error. But you want them to be successful. And obviously NASA wants them to be successful. So they have multiple options, multiple missions, multiple rides, and longevity into the future. So remains to be seen, but hopefully we do see a human test flight from Boeing later this year, which is their plan, so that next year it's in full operation.
And if and when it does pass muster, it'll enter service as only the second human transportation system to ferry astronauts into orbit. SpaceX got there first, but it's not to say that Boeing can't catch up and be just as valuable.
Yeah, look, once it's operating, once it's going, no one's going to really care, to be honest, about this. It's just getting to that stage. But at some point, it does have to be there. Otherwise, NASA's not going to wait indefinitely for it to be an option.
Equatorial Launch Australia made some pretty significant inroads for our space industry, launching a NASA sounding rocket 300 kilometres into the atmosphere. The American Space Agency's first commercial rocket launch, our first commercial rocket launch, and NASA's first launch here in Australia since 1995.
And it was exciting for the NASA people as well. In a lot of cases, some of them, a few of the people who I knew, some of their projects, they've been wanting to get down there for 10 years. In fact, the instrument on the second mission that at some point will launch, Sistine, when Kevin France and his team designed it, they designed it with the intention of looking at Alpha Centauri from the south. That was like the main goal of this. They flew it before in the north to look at another target while they're waiting, but this was always been their goal. So it's a really big step for everyone, so to speak, in this industry, not just necessarily in Australia. And I think that's an exciting thing for what is in store as more and more of facilities and rockets come on board.
The first of 3 launches, each with a specific scientific mission, only achievable here in the Southern Hemisphere. We do have some value.
That's right. And that's the critical point of these sounding rockets, is these targets purely are Southern Hemisphere targets. Dan McCannon, who is the PI of the X-ray quantum calorimeter, which was the first launch, when that was first built in 96, he was the last NASA launch in Australia on his first launch. So it was a nice completing the circle of this is the final launch of the payload, coming back to the point of origin, so to speak. So it was quite a nice historical loop for him. And with the second and third ones looking in the ultraviolet light, just purely at Alpha Centauri, that bright star near the Southern Cross, the closest star to us besides obviously the sun. It is only visible from the Southern Hemisphere, and it's such an important object to study. And you have to do it from the south. And, again, they've been wanting decade at least to come down here. So it's great for everyone to get those science goals, to get the science data, and then for the industry as a whole.
Now, if we didn't have ELA or the booming space industry that we have at the moment, how would NASA have achieved this scientific goal?
I mean, to be honest, they probably just wouldn't, right? I mean, that's the thing I don't think people realize is there's not really many other places they can land and do, especially in particular sounding rockets. The only facility elsewhere in the southern hemisphere, besides the stuff that's growing in Australia, is in French Guiana, where Ariane launches from, and ESA. But that's not what they do, and it's already tied up with other launches. There's 3 continents. There's Australia, there's South America, and then there's Africa. And these facilities don't exist in Africa. There's only one spaceport in South America. You're kind of running out of room here. They have launched from the Marshall Islands before and maybe could have pushed it, but that again is really tricky for the recoverability of the payload because it is an island and a small island chain as well. So for the recoverability aspect that they need for the scientific payload, not really doable. So maybe they could have set up in Antarctica, to be honest. That would be the only option. They have launched from the Arctic Circle, northern Alaska, and Svalbard in Sweden. But yeah, there's very few options. And again, I think this is why everyone overseas in particular is excited by what's happening in Australia, because there is limited options, but Australia just makes sense, not just with the geography, but just the way the land is set up, i.e. lots of remote land that you can do these things, is why I think we'll start seeing more and more launches flocking to the Southern Hemisphere here.
Well, you hosted the official live stream up in Arnhem Land. You were telling me off air through the week that it was a chaotic and hectic day, but I'm assuming in the best kind of way.
It was. Look, it was a lot of fun. I'll say that. But it was, everyone says, what was it like? And it was very Northern Territory. And it was amazing to see that. If I look to the right, I see a launch pad with a rocket that's carrying an X-ray imager. If I look a little bit further to my right, I see 6 tracking stations with LiDAR and some of the advanced technology NASA built. And if I go to the left, it's a caravan. It was a beautiful juxtaposition of that. But it just goes to show, and for the people who are overseas and are watching, it is hard to do this stuff up there. It is a remote part of the world. I think people view that parts of Australia, yes, you can go inland in parts of the US and stuff, but you'll still have the infrastructure there. It doesn't exist in a lot of these remote locations in Australia. Like, I had no phone coverage. It didn't exist. The only way we had data out was with the 3 Telstra ground stations that were built just for the facility. That was the only way data was out, and doing a live stream video and contacting from it, that was hard. And, when television outlets said, hey, this is happening, and they're like, wait, how the heck are we going to broadcast from there? Like, this was a head scratcher for so many people. So the fact that they can get that infrastructure to pull off a launch is such a huge feat unto itself. One that I don't think is really fully appreciated, that work that's happening. This isn't building a spaceport in Western Sydney, New South Wales, where, you could do stuff. I had to get a ride into town with the police because there just wasn't many cars around. Like, that's the nature of this location.
Well, your energy is captivating and contagious for our listeners and our viewers here on the show. I just want to play a quick snippet of launch.
4, 3, 2, 1, go!
That is the energy that I am talking about. It was a very, very exciting moment. Obviously, a few delays in there. We were live from here in the Trekzone studio, but watching you and just watching you having to fill that time and keep everyone engaged.
And it was fun. And it was the sort of thing where, it wasn't like, all right, it's going to be rainy for an hour, right? And in fact, that would have been easier to some degree if we just knew, hey, we're going to delay for an hour, because we're just like, all right, we're going to pause. But it was kind of like, all right, we got to reset to 3 minutes. And we had to reset to 3 minutes because that's the way the official count works. And that was the step they were at. But then it'd be 2 minutes later, we're starting again. So it's like, well, we can't really just leave it. Because you always thought that time was going to be the time. And for those who are watching you and we knew when we got to that 8-second count, that hurt us all. We were so close when we got to that 8-second one. Yeah. And that was the nature of it. The operator down there was watching it, and she didn't flinch. She realized it was reaching the safe parameters and called it even at 8 seconds, much to everyone's demise. We didn't get the full video of it, but the control room, when it was launched, I mean, even the NASA team was just ecstatic with the launch. They do this regularly from other sites. It was just show, how important, how excited they were as well, and how tedious that whole countdown had been because of all the stops and all the wins. So that infectious, I think, was everyone on the site channeling through me.
Absolutely. The thing that I loved is when I actually came back to the official live stream here on Trekzone, because I didn't have a producer in my ear, I didn't have your audio up, and there was a moment where I took your live coverage and all I heard was just the rain on the tin roof.
That was
this is brilliant.
And that was just goes to show, like, there was a point where it was, we didn't have a lot of period of rain, but you would have these huge, quick, sharp downpours. And it was loud. Like, this wasn't volume boosted. As you know, and probably our viewers know, I'm a loud person. So my mics are turned quite low down. Otherwise, I just make people, drown out their ears. So the fact that my low mic was that sensitive to pick up the rain on the roof, we were standing around like, we hope the roof holds at this point with how loud it sounded.
I love it. Well, we have talked about, when we've talked about the Aussie space industry, we've talked about how Australia's climate is quite under control and we can predict it well. And we have good seasons. We have the dry season in the north and all the rest of it. Generally, the dry season in winter is dry. There is no rain, but there's this massive East Coast low happening. It's coming off the Gulf. It's an incredible thing. It has delayed the second launch. Unfortunately, they delayed it for 24 hours till last night. And unfortunately, they had to make the call again about half an hour before they were due to launch. It's been postponed with no current time at the moment. That's obviously going to affect the third launch on the 12th as well. Any sort of ideas on when we're going to be able to see this one? I guess they're just watching forecasts at the moment.
Yeah, I mean, so, nominally each rocket had a 3-day launch window. And it's quite ironic because Sistine and talking to Kevin France, they were running ahead of time, in fact, in their preparation and getting ready. So they were kind of cruisy going in. So it's quite cruel that they were so far ahead of schedule and now they're waiting. The second launch is scheduled for the 12th of July, and they do need a gap between the second and third launches to get the third one set up, integrated. You also have to have a full day of dress rehearsal because you do that full countdown to make sure everything's working before you do it. So there is, I won't say they're running out of time, but there is a limited window that they can do. So I imagine what they're looking at is also what the weather is, as you said, like for next week, because if it's going to be stable, maybe they can then just normally move that 12 July launch back a day or two, knowing that the winds should be better then, and then say, all right, well, that still gives us this extra day. And I think they also just want to check what is the wind doing this morning. As you said, they made the call early on Monday to postpone it because it was very clear it was not cooperating. So, are they going to just say, hey, we think we can do it? As you said, they did do it. The countdown does start 8 hours ahead of time. So they went through 7.5 hours of getting ready. This is not a, hey, we're just doing this for fun. They went through the whole process and it just wasn't going to work because there is a short 3-hour window on each day for each launch. And it was clear that wasn't going to happen in that 3 hours. So I think we'll probably see, based on what the winds are doing today, whether they say we just can't do it today, we're going to have to look tomorrow. And as you said, that directly will affect the launch of the 12th and whether they need to move it out a day or two or not. And look, they with all the infrastructure and all the effort here, they want to maximize getting both of these rockets up. That is the goal. But there are restrictions in the legal flight licenses and permits and all that sort of stuff and safety and recoverability. So, it is not a finite thing they can keep delaying forever. But, we do see weather delays everywhere else, right? This is not
exactly.
The only unique thing about it, as you said, is this is happening during the dry season when it just shouldn't happen. But as you said, there's been torrential rain on the east coast of Australia which is just symptomatic of what's happening up there. In the grand scheme of things.
Let's get to southern New South Wales now, the Snowy Mountains, an awesome part of the country. We did tease you a little bit there, Brad. You were there to confirm some space debris. How did it land on your desk to investigate?
So it was one of these things where when eventually they found it, they were trying to get answers, right? They were trying to get people to figuring out what it was. They contacted formal groups like the Space Agency. No one replied. They contacted a number of groups. No one was kind of replying. And then in the Snowies, the ABC Southeast radio station bureau covers that area, and I do a regular space chat with them. And so they got onto that saying, hey, could they ask me if what I thought it was? And so the radio station said, hey, we got someone who thinks they have space junk. Could you take a look at it? And I'm like, all right. And then I got some of the photos. I'm like, whoa, all right, this is sizable. And then so I drove out the next day because luckily it's actually not too far from me in Canberra. It was a relatively short being 3-hour drive.
I love it. There's Mick Miner standing next to the obelisk, as I'm calling it. I'm going to have a quick question about that with our sci-fi background for you in a second. But there was a loud bang, presumably the sonic boom of re-entry heard across the Snowies and as far away as Albury, Wagga Wagga and Canberra back on July 9. That's likely when these pieces came back to Earth, isn't it?
Yeah, and this is kind of why we got so excited is we did have the SpaceX One Crew trunk re-entering on that Saturday over the area. A lot of people, as you said, heard and saw it, so we knew it re-entered, we knew it broke apart. And then when they said their location, Dalgety isn't a very big town. I had to verify exactly where it was on the map just to make sure, looking at the orbit and trajectory of the crew capsule trunk, I was like, oh, that's like spot on, right where you expect. So that was exciting to have as well.
Well, Mick Miners is the lucky man with that black obelisk sticking out of the ground. Did you get any 2001 vibes when you drove up to it, Brad?
Kinda, to be honest, kinda. Because firstly, from his gate to the site, it's a big trek, it's a big drive. You had to hop in his ute, and then you finally see it on the hill. And at first it looks like a burnt tree from a distance. And so you can kind of see why this thing landed on the 9th and he didn't discover it until the 25th, right? It was just kind of sitting there, not extremely obvious. And then you get closer up and it's like, that is weird. And it felt very obelisk style, peering at you, that some weird portal was going to open up type thing if I got it close. But it didn't. I'm here.
And there's some early humans standing around in awe and admiring it. What I find really interesting, and that's how it was left. It actually went into the ground, didn't it? It hasn't been stood up for photos.
No, that is it. He found it in the ground, and I think that's the thing is, had it been laying down more, he may have missed it for even longer. But it was found like that. There was no changing of it, and that's how it stays for the moment. It's still speared into the ground there.
Just incredible. Well, CASA, Australia's Civil Aviation Safety Authority, told Mick's neighbour, Jock Wallace, to call NASA and report his piece of space debris. So 2 bits of space debris in nearby fields. I am curious, Brad, is there a specific number or extension to call over at NASA for this sort of thing? What exactly do you do in this situation?
Well, it's funny because it's actually not NASA's thing. It's actually the FAA that manages this from the US side. And then on the Australian side, it's the Australian Space Agency, and they're the ones ultimately who are responsible. And after going down, as I left, I called the Space Agency, said, hey, look, this is what's going on. And then they visited Mick and Jock the next day to sort that formal process out. But it's kind of this thing. It is a rare event, so people don't necessarily know what to do or who to call, or there's not this, hey, I found space junk in my sheep paddock form that you fill out and it's solved. There are very few normal processes involved with this.
I think what is brilliant though, for it to land in Australia, it could only land in one place, and that's in a bloody sheep paddock. I think that is brilliant.
I know. It's perfect. It couldn't be more stereotypical if you lined it up. But look, it's a cool thing. It's amazing that it worked. It's amazing that also no one got hurt. And it was cool to be part of it. Again, it was such a rare event.
And I think just knowing that it's gone into the ground, speared into the ground, it just really shows A, how fast it was going, and B, what could have actually happened if Australia isn't 90% sheep paddock.
Yeah. No, that's right. I mean, had this happened further to the west over Jindabyne when lots of people were skiing or something like that, lots of different options, that would not be good. Yeah, I think the short of it is.
Exactly right. And this is possibly the largest piece of documented debris in Australia since Skylab. An important qualifier there in documented, but we'll see Skylab crash tests in our next story. I've picked up a couple of photos, but just incredible that being as vast as we are, thankfully we're not that heavily populated. These things happen. So more of this potentially could be happening.
As he said, documented and key because there are a lot of things that you have to go to know that it is space junk, where it's from, what it belonged to. And so it is rare. There's only a handful of documented cases because of the nature of how complex it is. It's one thing to find something weird, then also know where it came from, when it came down. And so we were just kind of lucky in the circumstances that prevailed that we were able to say, pretty definitively that it's there. There is a overall other key to this, and that is there are part numbers on it. So it's something that SpaceX can validate and say, yeah, those are our part numbers.
And goes into space law then, if there's any damage to the property.
The damages, liability, and ownership, and so quite literally, there is this international incident between the Australian Space Agency and FAA going on right now about what's happening, who does it, what to from here, all these sorts of things. So it's a very interesting scenario that Mick and Chalk find themselves in.
Well, on to James Webb now, and Hubble's successor has measured carbon dioxide in an exoplanet's atmosphere for the very first time, Brad.
And this was a really important thing. One of the things that we failed, I think, is publicly in that first batch of JWST images was the measurement of the exoplanet atmosphere. They measured WASP-76b, which showed a lot of water, and it was this kind of steamy planet. And this was always one of the big science goals, was to measure exoplanet atmospheres. And now, as you said, with WASP-39b, a different planet, they've been able to detect carbon dioxide. Now, carbon dioxide is very important. We were just talking about in the highlights, converting Martian carbon dioxide into oxygen. Venus has a lot of carbon dioxide as well. Earth has some. It's quite common in some of the Earth rocky-like planets in our solar system, and having that kind of first big detection in another system outside of our own solar system is a really important thing. This is going to be a really cool step and a really important step that in our understanding of planetary systems, exoplanets, and down the road, what that means for habitability.
Well, transmission spectroscopy was the method of choice to identify the elements present in the atmosphere. Talk us through that process, Brad.
You're essentially looking at light coming through the atmosphere of the star. And so what you look at is you can measure the light of the star and then the atmosphere of the planet. Sorry, I should have said the light coming through the atmosphere of the planet from that star. And so you can kind of subtract the two. You take a measurement of what the elements are in the star, what the elements you see of the light coming through that planet due to that star, subtract the two, and what's left is from the exoplanet. And this has been done a few times. This isn't a new technique that JWST has invented. This has been around, but it's a very hard technique because you need to be able to precisely break up the colors of light for a very small thing very accurately. And so when James Webb was built, by looking in the infrared and with a bigger mirror in space, it can do it in a way that we previously haven't been able to do before. And so it's a really cool, exciting technique. One that, as you said, we've already that was the second planet, and now there's heaps more lined up already by JWST to start doing this. We've moved from the past decade or two just realizing how many planets are out there, now to starting to realize what are those planets like in terms of their atmospheres. And that's a big deal. Just to put this in a scale, if you were to look at our solar system from afar, Venus, Earth, and Mars, from the previous methods we've been doing, would kind of actually be categorized the same. We're all in the habitable zone. Some are on the border, some are in the middle. We're roughly the same size. Venus and Earth are almost very close. Mars is a bit smaller. So you would kind of think maybe there's 3 Earth-like planets. What makes us different, one of the big things, is the atmosphere, and that's that step that JWST is taking.
And the release of this data is part of the early release science program. Webb has also suffered its own set of delays, which we covered on Talkin Science before launch. So this is a nice way to get instant feedback on the success of the scope, isn't it, Brad?
It is, and they're just chugging through the results of this. And I think this is why so many of us were excited. It was benefiting so many different areas of science. We saw the deep images of galaxies. We're seeing galaxies images turned out. We found supernova already with JWST, images of Jupiter, exoplanets. And this is why we've all been excited, is it was going to benefit so many different areas of astrophysics. And it's proving in 3 months kind of operation now to be delivering the goods.
Now, this one's cool. Webb has snapped its first images of an exoplanet. These are actual images. It's kind of covered by all of the graphics there, but it will be up. This one is very, very cool. A direct image of an exoplanet, Brad.
Exactly. So, when you think about what we know about exoplanets, we find them either from the planet moving in front of the star, and we look at the dip of the light, the transit method, a similar way, but then we can measure the atmosphere of the planet, or a few other techniques. A lot of them are based on the measurements of the properties of the planet without seeing the planet itself. And here you're starting to see the first images. This is directly of the planet. That light is of the star, marked as the star, bouncing off the planet, shining it up, and us being able to see it. Just as people thousands of years ago would go out to the nighttime sky and see objects in the sky that move differently from the other stars, and those were the planets. Just as you can go out tonight and see Jupiter and Saturn and Venus in the nighttime sky, this is how we're seeing it now for the first time around a solar system way beyond our own scale. And this is another one of those big steps that JWST has done. The direct detection is a very powerful tool. Again, it's very hard. You need a really big telescope with very good imaging and the colors of light to see it. It's been hard from the ground. We have done this again on the ground. All of these techniques, the atmosphere and this, have been done previously on Earth. It's just so much easier and better with JWST.
That leads into my next question. We as humanity have a folder of just 20 direct images of exoplanets, but they're lacking that key detail, as you say, being snapped from the ground. I believe this is the first time we've seen one from a space telescope.
It is, and not the last. I mean, there's a heap of these that are in the pipeline to start imaging. And so this is kind of the exciting thing where we find ourselves in the decade of exoplanets. And it's just an interesting topic because the very first planet was discovered 30 years ago. 1992, the first planet around another star was detected. So in 30 years, we've gone from not even knowing another planet existed in another star to seeing a few, to with Kepler saying, hey, they're common, to tests, realizing there are just so many out there, to now measuring the details of these planets. This is what the next decade is about. JWST and new instruments being built on the ground, measuring the properties of these stars, telescopes in ESO and at VLT in Chile, instruments now at Siding Spring in Australia are all into this world of measuring the properties and details of these planets. And so we'll go from putting a picture together of just how many planets are out there to what are all these planets like relative to our solar system, and the atmospheres, the gases, the sizes, the temperatures, the compositions, all these really big questions, really putting that bigger picture together of what these planetary systems are like.
And researchers discovered James Webb was 10 times better than estimated at getting these shots, these direct images. That's also a nice surprise as well, isn't it, Brad?
Yeah, that's the thing. Is like, it's one of those things, you build the mission for a certain spec, and when the quality is better, and this has been across the board, even with the first supernova that has been found from friends of mine in Baltimore, it was, hey, we didn't expect it this good and this quick. So JWST is delivering beyond what we imagined. And so that's the exciting thing. It's transforming it even more than what we thought it'd be transformed by. And we thought that was a lot.
Well, the telescope is in such high demand that these images are going to be likely be a bit of a treat rather than everyday occurrence, really, though, aren't they, Brad?
Yeah, and this is the thing. There are so many different projects that are on board. Telescopes are measured by how subscription rate, what we say. So for how many hours are available, how many hours are asked. For Hubble, that's like 10 to 15 times. So for every hour on Hubble, there's 10 to 15 times worth of asking. The next call for James Webb Space Telescope, so they go every year, is just about to come out. So we'll all be spending our time writing our ideas, going through a panel, then being vetted. You can imagine that it will be dramatically more than that now that people are seeing, hey, the data is here, it's coming through. And this is already with all the programs already approved. So it's going to be a lot. And this is the exciting thing, is we have decades, hopefully, worth of these discoveries to be made.
NASA's DART mission, Brad, it's had a successful crash landing. Talk us through the aim of this one.
You know, crash landing is an interesting term because, well, it's very rare do you want that to be the result. You know, usually if you have a crash, it's something's gone wrong. In this case, it went exactly right. And so DART was a probe built to deliberately hit into an asteroid to see, could we alter the path of an asteroid if it was oncoming? And so we saw last week this whole mission unfold. And as you're seeing the video here, this probe autonomously kind of guide into the rock, slam into the rock, and knock it off. So a cool event, essentially. And there was two, I think, key parts of success here. One, hitting it, which we know it did. And we know it based on, we lost the signal. And as you've been seeing, ground-based telescopes in James Webb and Hubble spotted the resultant collision and explosion. And then how much do we move its orbit? Now, that's going to take a longer time to measure, but eventually we'll get that answer.
And it's left a 10,000 kilometre debris trail. Is that going to pose any future problems for exploring the solar system, Brad? Thinking years and decades in advance.
I mean, not really. I mean, the density is going to be so low, and a lot of these things will be so small, it'd be no different than a meteor shower. You know, these things are not as dramatic as it may seem. This asteroid is quite small, so, you know, we may have a new meteor shower at some point. Potentially, more likely, there will be a case where as another probe gets closer to the Earth, or to this asteroid, because there will be a follow-up mission called Hera, built by the Europeans, that's going to land in the crater in a few years' time. They'll obviously have to navigate that, but that was all part of the mission planning. And also, one of the things they wanted to study, because with all of this rock and plume that came out of it, it was a good chance of measuring in a better way the composition, in particular stuff that may have been underneath the surface that we normally couldn't see before. As in, you know, when we measure these asteroids competitions, we only see it from the surface. We don't see underneath the surface. Are there different layers? Are there different composition? Who knows? This was a free chance to see that.
Not like the images we're showing on screen. There was absolutely no risk to Earth, and some great images, as you say, captured by ground telescopes, as well as Hubble and James Webb. We saw those just before Hubble, the blue images, James Webb, the red images, especially in a great spot to view this impact, this forced crash landing, this deliberate crash landing, as it were, all in the name of science.
Yeah, look, and telescopes around the world were trained to monitor this thing, watch it, both the impact and now that resulting, how much the orbit has changed. So as you said, all in the name of, can we do this if we need? Now, again, there is no risk of this asteroid or any asteroids. And, you know, there's probably a few subtleties in this mission that maybe weren't as appreciated. You know, we had never seen up close this asteroid before. So the probe had to autonomously track and lock on to the right asteroid. It could have chosen the wrong feature and went too high or to the side. You know, it could have sideswiped. It could have accidentally hit the bigger one. So many things about where can we actually have a probe that can guide itself into the center and nudge it. That's harder than it seems. Imagine, you know, we talk a lot about on Earth, self-driving cars. Imagine you're trying to have a self-driving car, but it doesn't know what a road is. It doesn't know where it's going, and it's not going to work when it gets to its destination. That's what they had to do in space from 11 million kilometers away. So there was a lot of work needed just to get that part to work. So that's a huge success. And now we'll measure exactly how much that orbit has changed by how much the orbit of the smaller one has changed around the bigger one. It's going to take about a month or two to do because you need a number of times of this asteroid going around to precisely measure how much that orbit has changed, because you're really only talking about a shift of about 1 to 2 millimeters per second. It's actually not a lot. Over time, that's 20 to 60 kilometers per year. Now, that can be enough if you need it to be, but we're not talking about a big shift, and that's also what people wanted. We didn't want a big shift.
One of those telescopes that's going to keep an eye on it is Hubble. It's going to keep an eye on Dimorphos 10 times over the next 3 weeks. Long-term analysis, as you're saying here, Brad, very, very key to working out mission success.
There's a network of telescopes on the ground and in space that will just keep monitoring this thing until we have that answer. And I think that's the exciting bit of it. It just goes to show how these facilities really all fit together. It's not just always one instrument. Even when Hubble's doing discoveries, it's usually working with other telescopes on the ground or other telescopes in space, as we saw with James Webb and Hubble doing the work together as well.
The Australian Space Agency has agreed to collaborate on the next Japanese sample return mission, Brad. The precious cargo will land in South Australia, just like Hayabusa 2 and Hayabusa 1 at the end of this decade, and the capsule will contain samples from a place we haven't been to yet.
That's right. The moons of Mars are very different in a lot of ways than our moon. They're tiny. Our moon is a little bit smaller than Australia. Those moons are smaller than a city. They're only 16 and 25 kilometers wide. We think they're captured asteroids. They orbit so close to Mars that they're actually closer than our geosynchronous satellites around the Earth. They're very close. And so because of this, the idea is, well, we don't really know a lot about these moons. Let's go and study them in detail and land and grab samples. But also because of how close they are, there's a belief there may be some rocks and samples of meteorites that have crashed into Mars, flown out, been ejected out, and actually landed on those moons, so that you could potentially grab some Mars rocks as well, in addition to the rocks of the moons themselves. So very unique, very ambitious, and an exciting mission as part of this growing cooperation between JAXA and Australia.
Now, with the timeline, you can tell JAXA have great confidence, the Japanese Space Agency, and experience as well in this. We know that they've done Hayabusa 2 as well. They're planning on launching MMX, launching September 2024, landing on Phobos in August 2025, and returning to Earth in July 2029. It's almost becoming the start of a decade-long tradition. Hayabusa in 2010, Hayabusa 2 in 2020, and now 2029 for this MMX mission, Brad.
That's right. Yeah, and this is kind of the exciting thing, is you can make these missions kind of turning them out quite regularly. And the hardest part to some degree here is just how long it takes to get to Mars. These timings are because it'll take 6 months alone-ish to get to Mars, and then you have to wait for the orbits to line up back. There will also be other countries that have cooperated, just as Hayabusa 2. CNES and DLR, the French and German space agencies, will be building a probe to land, a rover to land on Phobos, the moon as well, just as they landed some craft on Ryugu with Hayabusa 2. They're also working with Japanese television to produce the first 8K television images of the moons of Mars and Mars itself. So, our views of Mars are going to get a whole lot crisper coming there. And so these are the cool things that you can do just by the sheer amount of cooperation, working together. And so this is definitely a great mission for Australia to be a part of.
I'm just thinking of our friends at Tidbinbilla, Glenn Nagel and everyone having to process that 8K data as it beams down. That is going to be a huge file for them to download and have loss prevention on.
Yeah, so I think people may be retiring towards the end of the decade, so they don't have to deal with that. I don't know. But yes, no, there's a lot of work that will happen as part of this. And as you said, broadly across lots of sectors in Australia. Some of these samples, as with Hayabusa 2 from the Mars mission, will stay in Australia to be studied by Australian scientists as well, with both places Phil Bland and Curtin and Trevor Ireland at University of Queensland being involved in these past and future missions. So really exciting opportunities as well for the science to evolve and happen, and Australia is part of it.
Now, we've spent a long time looking at Mars, exploring the Red Planet surface, orbiting, roving, and even droning. But this will be the first mission to a satellite of Mars. What are the burning questions right now that the Martian Moon's exploration, MMX, hopes to answer?
So there's a few, right? There is, exactly what and how are these asteroids made up of. We believe they're captured asteroids, but we're not exactly sure. Is there any sign of its history? There's some models that suggest the moons of Mars are slowly migrating towards Mars and may actually, and probably will, due to its gravity, break up in 20 to 40 million years. And as they break up, they'll kind of spread this huge area around as a ring almost. And some models have suggested that gravity has actually brought that back together to form almost a cyclical moon potentially. So a little bit about their history, the history then of Mars itself. If they can find Mars rocks, then that could be signs of massive bombardment by meteorites on the planet itself. So a huge range of different things there. And, we've spent a lot of things of rovers landing on Mars and studying them and samples of getting it back, but the moons have been neglected. And so if you want to understand the entire planetary system, just as you need to study our moon to help understand Earth, you need to do it with Phobos and Deimos as well.
And for a long time, the planets of our solar system were the focus. Now we seem to be shifting to the moons, planning underway for Titan and Io missions, and now Phobos. In general, as overall, what can the moons of the planets tell us? As you say, studying them helps us to understand the planets, but kind of, I guess, what are we looking for when we're studying these moons?
Yeah, there's a lot of interesting debate about the formation of moons as well. There seems to be multiple paths to some degree of how a moon can turn into a moon. Migration, moving towards it, being captured, being formed from a collision, or form completely different mechanisms like Jupiter and Saturn, which appear to be, their moons are larger than in some cases Mercury, and they have atmospheres. And so it's that interesting dynamic between the moon and the planet itself. And then obviously, is there signs of life in some of these places? So it's, there's 120 something moons, I think, or so in our, maybe 130 in our solar system. That's more than the 8 planets we have. So that means there's a lot of bodies which are all very, very different. And then why also does Mars have moons at all? Mercury and Venus do not, Earth does, and Mars does as well. And again, Mars's moons and our moon appear to have very different past histories. So that tells you a lot about the planet itself. Does it give insight into the tilt of Mars, just as studying our moon gives insight into the tilt of Earth? So there's a lot of these different things that really start to build up the picture, both of potential exploration, the idea of life and habitability, and the creation of the systems themselves.
So many great stories, so little time to cover them all. Of course, missing in there was Artemis 1 successfully launching, flying around the moon, coming back and landing back on planet Earth. A huge milestone for the team at NASA. Everyone involved in that mission really made that happen. And looking forward next year to Artemis 2, Artemis 3 beyond that, a crewed mission to the surface. The first woman and the first person of colour, as well as the return of man to the lunar surface. Looking forward to all of that. Artemis 2 next year hopefully will be the crewed mission to lunar orbit, the first time that we've done that since the 70s. So very much looking forward to all of that. Of course, I also missed too, as I put my phone on silent, I missed too the Southern Launch mission attempt. We were down there at the Whalers Way Orbital Launch Complex at the start of December as they attempted to launch those 2 Kestrel 1 rockets from AT space. Unfortunately, they didn't get off the ground. They had weather issues, comms issues, and leakage as well. So unfortunately, we didn't see a rocket launch. We went all that way for nothing. But I tell you what, it was amazing to be there. It was amazing to meet Lloyd Damp in person, catch up with all of the Southern Launch team that I've been emailing and calling over the last couple of years, and to actually see them in person and see that passion that they have was just absolutely incredible. To also be in Port Lincoln for the very first time was awesome as well, seeing the beautiful landscape that it is, driving over from Adelaide as well. It's a beautiful part of the country that South Australia has. met some of the locals and discovered some of the issues that are presenting themselves that those locals really want, the local residents, those local people really want to be addressed. Unfortunately, no one would speak with me on camera because I really wanted to chat about those issues. I've looked at the environmental impact statement that Southern Launch meticulously put together. All of the concerns are addressed in there, but it would still be lovely to sit down with someone from the Eyre Peninsula Wildlife Campaign, those local residents that are passionate about that area, and absolutely rightfully so. It's a beautiful part of the world. And it just coincides with being the best place to launch into polar orbit. So be on the lookout for more Southern Launch coverage in the new year. Going to be definitely doing stuff with them. I hear that another launch window may be opening up in February as well, so we'll be keeping an eye on that as well. Gilmore Space next year looking to launch from the Abbott Point Orbital Launch Complex as well. They're building rockets. I featured them in one of those highlights. We saw that they have successfully tested engines and they're really powering ahead with all the great stuff. Equatorial Launch Australia as well, successfully launching 3 sounding rockets of NASA's design into straight up and straight back down as well. That was incredible to see that from East Arnhem Land as well. Plenty of other science and space moving and shaking done throughout the year as well. Of course, the Deep Space Communication Complex, we did check in with Glenn Nagel from down there as well and caught up on all things communication. The DART mission was a success, saw that in the highlights from the year as well. So much more great stuff and plenty more to come in the new year. Not forgetting too, the Mars Insight lander, we lost that one. Very unfortunate, but we picked up samples on the Red Planet as well, and so much more happening, not just here in Australia, which is Trekzone's focus, but also around the world as well. So looking forward to covering all of that even more in depth next year as we return to long-form Talkin Science episodes weekly, starting without any delay on the very first Tuesday. We're moving it to Wednesday, actually. This is live and unscripted. Moving Talkin Science to Wednesdays, and that is going to be starting on the very first Wednesday of 2023, which is just a few days away. So looking forward to all of that. It's going to be absolutely incredible. So much stuff to cover. Not going to want to miss a moment. So don't forget to get subscribed to Trekzone to catch up with everything. And of course, our socials as well. Twitter, Facebook, Instagram. We're all there. We're all happening. And we are kicking off non-stop podcasting once again next year from January 2. Be on the lookout for all of that and stick around for tomorrow on Trekzone TV. We're going to go live for a countdown to the new year on Australian Eastern Daylight Time with a wrap of all of the best Trekzone conversations from the year as well. So be on the lookout for that. Looking forward to podcasting, Talkin Science all throughout 2023. For now, though, I'm Matt Miller. Thanks so much for watching. I'll catch you again real soon.